Okay, so arrays then. Alright, so this introduces a problem to start with, saying, well, which is kind of similar to what we did when we used loops, various loops to resolve something. What if you had to do 100 of something? It's really inefficient to copy and paste 100 commands if it's basically the same command. So we learned to use a loop to resolve that problem, and it was much more efficient. You have a similar problem if you have, let's say, a group of something that's really related, a group of numbers that you need to compute, the average. So you get a bunch of grades, 20, 30, 40 grades, and you want to compute the average. Well, it's kind of inefficient to create 20, 30, 40 integer variables. Not too inefficient, but it's a lot of work, and then you're kind of stuck with that number. So, what if you say, well, I'll create 20 integers, and then you wind up having 21 students? Or you create 40 integers, and you only have 15 students, and you've wasted some memory. So, arrays are basically a solution for this when you have to deal with, groups of related data. It's like a list, basically. A list of items. A one-dimensional array, which is all we're going to talk about tonight, is essentially a list of items, like a shopping list. Okay, I'm not sure if we looked at this analyze numbers or not. Do I have it? Don't look like I do. Alright. It's interesting. That's what I did. So some of the objectives we're going to look at, we're going to look at why arrays are necessary in programming. Kind of give you a quick answer there already. They're very useful if you have a list of things you need to do, a list of related data. We'll look at how to declare arrays, create arrays, find out how many items are in the list. We will look at how to access them with something called an index variable, which is simply a list. So if you have a shopping list with 15 items on it, you start at the very top. The very first item on that list is number one, the first item on the list. The second is the second, and the third is the third, and so forth. Arrays have, which are essentially a list, have this sort of concept as well. They call it an index. And the main difference between the array and the array index and a index on a shopping list is that arrays are zero-based, meaning they start with 0. So 0 is 1, and 1 is 2, and 2 is 3, and so forth. So we'll look at some examples. There's a special for loop for arrays. We'll look at that, and we'll look at some more examples as well, using random number generators, copying arrays from one to the other, develop and invoke methods, look at variable length argument lists, and look at all kinds of different things as well. Searching to arrays, two different types of searches called a linear search and a binary search. How to sort arrays, and also there's a specific array class in Java that we'll look at as well. Okay, let's see where we're at with this. Analyzing numbers. Okay, so this is the one I was looking for. We probably need to create that one. No, it looks like I put these in the wrong place. That's what happened. Shopping list as well. It's up there. Alright. So analyze numbers. This example we have from the web. doesn't do a heck of a lot. It's going to ask you for some numbers, and it's going to sum them up. It's going to figure out the average of all the numbers, and it's going to then tell you what the average is. It's going to use another for loop. It's going to use a for loop to get 10 numbers from you, essentially, because number of elements is set to 10. It's going to create an array, and then it's going to enter all those. It's going to sum them up. And it's going to figure out also, after it figures out the average, it's going to use a second for loop to figure out how many numbers are above average and keep a count of them. And then it's just going to display all that out. So we'll go ahead and run this. So now it wants me to enter a number. It'll be real simple and just enter them in order. So it tells you the average is 5.5, and the number of elements above the average is 5, which would make sense. 6, 7, 8, 9, and 10 would be above average. And if we added those all up, we would have an average of 5.5. All right. I had another example here called a shopping list, which is going to prompt you for some items on a shopping list, and just print them back out. So if we enter here, milk, cheese, bread, fish, wine, honey, gee, what else do we want? Yogurt, chicken, cereal, one more, and there we go. So it's using an array to store all those elements, and then we'll print them back out. Now we touched on arrays a little bit on Tuesday. Does anyone have any questions so far? Okay, so the array, it's always an array of something. So this open bracket, close bracket means it's an array, and the data type of string means it's an array of strings. And how many are you? You're creating it just like a class, just like an object. New string, but it's instead of in between parentheses, it's in between square brackets, and count, which is the number of elements to create. And so this list, items, will be an array or a list of 10. And you can put 10 distinct values in there. Under Analyze Numbers, we're basically doing the same thing. Creating a double array of, again, 10 items. And arrays and loops work in tandem. I mean, you almost always, when you have dealing with arrays, you usually have a loop, usually a for loop, to process that array somehow. Either prompting for data or displaying the data, summing it up, analyzing it, whatever. So arrays and loops, particularly for loops, go hand in hand. They go so hand in hand that later on we're going to learn about a sort of specialized version of the for loop for dealing with arrays. So again, here, if you create an array called myList of doubles, 10 of them, so it's an array of doubles, 10 of them. This is the way, this looks like a list. This is a list of numbers. And remember that we said the arrays begin with 0. 0 is actually the first number, not 1. So 0 is the first element, is 5.6. And the way this works is it's basically an offset. We used to call these offsets or subsets a long time ago. my list points to the first place in location in memory where the list is, and the array is going to use a continuous spot of memory. So let's say double is 8 bytes, which I think it usually is, and we want 10 of them. So that means that the computer, the Java, through the operating system, is going to have to create 8 times 10, or it's going to need 80 bytes of memory to store all this information. And my list actually points to the very first byte in memory. And this index element is actually, we used to call it an offset. It's an offset from it. And the way you get the offset is you take the actual number in there and you multiply the times the number of bytes in that data type, in this case 8, and you add that to the starting place. So if my list sub 0 or offset 0 is 100, or my list is 100, let's say that's the memory location it starts at, then my list offset 0 times 8 is also 100, because 0 times 8 is 0. My list offset 1 times 8 is 108. 100 plus 1 times 8. So now 4.5 is at memory location 108. My list offset 2 times 8 is at 116. Right? 2 times 8 is 16, added to the original starting place of 100. So this is actually a continuous block of memory. So it is literally a list. You have multiple, and these could have been, all different variables. My list 1, my list 2, my list 3, literally without the array bracket. Okay, and so more common term is usually sub. You hear that it's like a sub or subset. So it's like my list sub 0 would be the first element. My list sub 1 would be the second, and so forth. So that's kind of some terminology that's basically used on it. Goes through, okay, the data type. So it's an array of data type, and this is the variable or the array reference variable. Example again, array of doubles, my list. And you can do that like that. You could do it this way as well, as it's saying, but it's not preferred. They think it's more readable to do it the other way around. So for example, this and this are exactly the same. They're just not liked, essentially. This is considered more readable. This is the main difference. But otherwise, it's okay. Creating the arrays. So creating the array reference, and you can do this on 2 different lines, because you can say my list is equal to new double. So my list was previously on a previous line created as a double array or an array of doubles, and now, or defined, I shouldn't say created, it was defined as an array of doubles. And now we're actually creating those doubles. Right? The new actually creates it. And again, 0 would be the first element, and 9 would actually be the last element, which would be the 10th element. So it's always off by 1, because arrays and most things in computer languages start their counting at 1. So some examples here. This is a valid declaration. Just like this, double my list equals new double. Or you can do it in different lines. Again, this is valid as well, but it's just not preferred. It's preferred that you do it this way. Once an array is created, its size is fixed. So you can't grow or shrink the array. That's kind of a problem. There are some, this is sort of a traditional array. It's static in size. Once you create the size, it's done. You can't shrink it, or grow it. There are other types of arrays and other types of data structures that act like arrays that actually are mutable or changeable. You can change the size, add and subtract from them, but traditional arrays are not. And right now we're just looking at a traditional array. Default values, numeric data types always get 0. I think this is the null data type for char types. False for booleans. So what if you type mylist sub 10, then mylist sub 20? You'll get an error. You'll get a nasty error. We did the shopping list. Right, so if I attempted here to do something like this, sub 20, what would happen? Or actually, let's do it before we even do all that. Let's just, put it right there. What would happen? We'll see. It's going to be nasty. Boom. Exception in thread main. Array index out of bounds. So it's basically telling you, you tried to access something that doesn't exist. This is a little like saying you want to go to the 20th floor of a 10th floor building. The elevator ain't going there. And that's what this is saying, right? So the building was constructed for 10 floors, and you're going in there and saying, I want to go to the 20th floor. Ain't going to happen. Basically is what this thing is saying. There aren't 20 floors in this building. There's 10, and that's it. So basically that's what happens. You get an error message like that. So we talked about the index again as being 0-based, and so the starts at 0, and the last item will always be the length of the array minus 1, right? Because if it's 0 to 9, that's 10 elements, so the length is 10, but you're counting them based on 0 to 9. So that gets a little confusing at first. Fortunately, some of the new for loop that's created, and just sort of like using for loops, you kind of forget about that eventually. And this is an index variable usually. This thing can be called whatever you want it to be called, but it acts like an index. You can certainly do something like this. You can use any of these numbers however you want to. Once it's created, and let's say these are all doubles, saying this is equal to this plus this just means you're going to take the value in this double, add it to the value in this double, and store it in this double. It's the same as having 3 non-array doubles. It's, saying C equals A plus B. It's really the same. There's no real difference. Array initializer. So this is a neat little shortcut way of doing it. Basically, you do something like this if you know the values. If the values for the array are static, then you go ahead and do something like this, meaning static at compilation time, meaning you know what they're going to be and they're not going to change. So we could say right out here, an example might be, let's say marital statuses. String marital. Usually we do this equal to married, let's say single, divorced, widowed, and there's, all kinds of different options, right? Actually, this would probably be married. Something like that. This is generally used, and it's nice because you create. It's usually only used when for lists, like little drop-down lists. You can prompt the user for the size. Yes, you can do that, and you can create the array based on the size they enter. You definitely could do that. Yeah. So here is an example of doing it all on one line, and this is kind of useful. When you've got something that doesn't change, marital statuses don't generally change. They're fixed. They're static. They don't change. And as far as what you were saying there earlier, I certainly could. I could just say, well, let me put that back there. We're not going to use it, but I could certainly say system.out.print how many items will you purchase today? And then we could just say here, I can say, see what the input dot next int. And now everything will be driven on that, right? So if I enter 5, it'll only prompt me for 5 items. So if I say 5, now it's only going to ask me for 5. So yeah, you can do it that way if you want. All right, and this is the example here. So now, typically, this sort of notation is done when you've got a fairly small list and the numbers are unlikely to change, or the values are unlikely to change. Then you do this shortcut method. It's actually a pretty nice way of doing it. That's, again, the shorthand method. So this shorthand method is exactly equivalent to doing this and then assigning all these values. Again, that only works when you know what the values are at compilation time. It doesn't work at runtime. Right, okay. The other thing is the shorthand only works all in one fell swoop. So you can't break it down into 2 different commands. You have to do it as one command. So this doesn't work. How do I shut that off? All right. Any questions so far? So this quick test, which I've got here, and I think we did, yeah, it's basically the same thing, I think. Doesn't really do very much because it doesn't display anything. Well, actually, it does do quite a bit. It just doesn't display anything. So it's not obvious what it's doing. But it's using a for loop. It's summing up, or it looks like it's going to take value sub I is going to be the actual I value plus the value in the previous one. And then it makes 0 equal to the first one and the fourth one. Whatever that does. We could run it, but absolutely nothing will happen since it's all internal processing. But this thing kind of explains what's happening. It declares the array, creates an array, and assigns its reference to the value. So when they get created, they're initialized with 0. That would be the default. I becomes 1. I is less than 5. And it populates I with I plus whatever is there in the previous one, which is 0. Adds 1, it becomes 2. And then that becomes I, which is 2, plus the previous one, so that's 1. that goes, and now it's whatever's there, which is 3 plus the previous one, which is also 3, so it's 6. So you can see it's kind of, so now it's 4 plus 6 is 10. Then after I becomes 5, it's false, and this one says value sub 0 is equal to value sub 1 plus value sub 4. So that's 1 and 5, so 11. Okay, any questions so far?